Family courses in the cement industry. Presents to you. There will be a series of courses explained. Maintenance of rotary kilns. We followed the courses on supporting rollers. The third course discusses inclination of supporting rollers. Roller inclination. Why is rotary kiln inclined? The kiln is kept inclined, generally 3.0 to 3.5% slope, and rotating in order to convey material from feed end to discharge end. In case kiln is not having any slope or is horizontal, then in this case material will not move further and will get accumulated at kiln inlet only. Another definition of roller inclination. The reason why a cement kiln is inclined is as follows. A cement kiln is a steel tube lined internally with refractory bricks high in alumina, therefore very resistant to heat. Normal operating temperature 1450 to 1500 degree. Cooking. The rotary kiln is fed with flour, composition of a very finely boxed raw material. The inclined kiln rotates at a rotation speed which then allows 1. To stir the flour and thus the penetration of heat, and its homogenization. 2. The rotational movement of the material, which becomes with the inclination a spiral movement, so the material advances from the mouth of the kiln, entrance, to the exit where it reaches its softening temperature, and therefore becomes after its exit and its cooling of clinker. The inclination and the speed are the two parameters which are very important in the quality and the cost of the production. Roller inclination. Just like horizontal skewing, vertical skewing of a roller. Having a roller slope, different than the kiln slope, will also create a thrust force. See in the figure. Note of importance. Roller slope must not deviate from the kiln slope by more than 0.02%, 0.04% for old kilns. The direction of allowable deviation must be such that the roller pushes the kiln uphill. There are many types of measuring devices too. Measuring roller slope. See in the figure. Roller slope is measured with manual and inclinometer. The benefit of knowing your slope is so that you can create consistent, matched slope between your rollers, bases, and the unit in its entirety on your rotary kiln. Being aware of your slope can help ward off surprise issues such as unnecessary wear and poor thrust alignment. Inclinometer. To measuring roller slope. See in the figure. Due to its dimensioning, the inclinometer reads the percent slope directly. See in the figure. When the leveling bubbles are centered, the percent slope is read on the micrometer dial. See in the figure. Magnets allow mounting the inclinometer on horizontal or vertical surfaces. The inclinometer has a precision bubble level for each position. See in the figure. Important note. Check the roller slope with the inclinometer mounted on the shaft end. Take readings on both ends of the shaft and average them to eliminate the effect of roller shaft deflection. See in the figure. Using an inclinometer on a precision straight edge across a kiln base to determine the correct slope. The another device. See in the figure. Rotary inclinometer. Measures the axial inclinations of slow rotating parts during operation on rotary kilns. See this video how measuring by rotary inclinometer.
Use the rotary inclinometer. The rotary inclinometer is a measurement tool which measures the axial inclination of slow rotating parts such as rotary kilns during operation. It measures deviations in vertical direction with a high accuracy, which makes the alignment work much easier. To use the rotary inclinometer, follow strictly the local safety rules given by the respective plant and local authorities. The rotary inclinometer comes as a toolkit in a strong and tight transport case, which includes the following items: the rotary inclinometer itself, the heat shield, a shaft center adapter to reach into the bearing housings, a high-range Bluetooth adapter for USB, a battery charger with different country adapters, and in the lid, the manual, as well as the software for Windows, the TomTom Tools Measurement Studio. As a first step, the Bluetooth adapter has to be plugged into the laptop. To connect a tool, select it and click on the connect button. In order to perform the measurements, the roller shaft has to be accessed. When opening the cover, ensure to use proper tools and prevent any contamination of the bearing. Now, the inclination sensor, which is the main sensor, has to be calibrated on a rotating part. Attach the rotary inclinometer to the shaft center adapter and fit it to the kiln roller shaft. The calibration basically consists of two normal inclination measurements, which are performed on the same rotating part, but in different directions. That means, for example, like here on the support roller, once on the uphill side and once on the downhill side.
Roller and tire defects. Roller and tire defects. A hot rotary kiln is similar to a nylon bag full of water. The kiln stands over the supporter rollers, and the shell shows oscillation, because of the ring which is thicker than the shell. Ring presses the shell down and creates ovality. By the time the ovality carries itself to whole shell and creates a crank, the surface between ring and supporter roller reduces. During this part of the course, some roller and tire defects will be explained. See in this figure. In this case, if kiln rollers are skewed too much, the wear rate can be quite severe. And see this video from the side. When kiln tire and roller grinding resurfacing. See in this figure. In this case, excessive Hertz pressures on under-designed or poorly cast tires and rollers can result in severe pitting. See in this figure. In this case, the old practice of running a roller in a water bath is now thought to promote surface pitting and is no longer recommended. See in this figure. In this case, when rollers are misaligned or conical shaped, the kiln load is spread over too small an area. This causes high surface stresses, resulting in pitting. See in this figure. The following is noted. A defect on a roller may transfer to the tire, and vice versa. See in this figure. The following is noted. Roller or tires may wear to a conical shape. See in this figure. The following is noted. A tire running off the roller for a long time will wear into a step pattern. It is therefore necessary for the rotary kiln to move uphill and downhill regularly. See in this figure. The following is noted. Tire wobble can create a concave roller surface. Concave and convex wear present, the most common problem in kiln tire and support roller wear. In order to control the kiln axial thrust, the roller shafts are skewed, and this procedure has a direct effect on the mating surface profile of the support rollers and the tire. The axis of the roller shaft is no longer parallel to the axis of the tire. Consequently, the edges of the tire on both sides of the face will have higher load concentrations than at the center of the tire. When the rotary kiln operates in this condition for some time, the tire will have accelerated wear on its edges, giving it a convex shape. The support rollers are wider than the tire, hence the surface of the rollers will develop concave wear. Since this is the desired adjustment position of the rollers to control the axial thrust of the kiln, this kiln design makes concave and convex wear inevitable. Any problems beginning with tires and rollers can quickly propagate throughout the rest of the rotary kiln, resulting in 1. Increased shell vibrations. 2. Excessive load on the drive mechanism. 3. Damage to rotary kiln, inlet, and outlet seals. 4. Hot bearings. 5. Premature refractory lining failure. 6. Cracked foundations pads. 7. Increased wear and damage on the girth gear. We will review these problems from the site. This video shows. Take note of the following. The tire and supporting roller are not in complete contact. Can be overcome by roller's adjustment and skewing. And see this video. What is happening? And what is the solution in your opinion? Roller and tire reconditioning, grinding or resurfacing, is an excellent preventative maintenance measure that can keep your tires and support rollers in good condition, avoiding unnecessary damage, loss of production and downtime at your plant. In these figures we see there are many different shapes of tire grinding machines and rollers. Rollers and tires may be reconditioned by machining or grinding. Shown above is a lathe adapted for this purpose. From the site, I present to you this video, which shows the grinding process for supporting rollers. I have some notes to share. 1. Rollers are reconditioned while the kiln is in operation. 2. Also machining a kiln tire while the kiln is in operation. 3. This roller is being resurfaced by grinding rather than machining. 4. Also resurfacing a tire by grinding. See in this figure. The tire's edges must also be grinded, because in most cases it needs grinding. And see this video. Tire and roller edge defects must also be removed. Edges should then be chamfered. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.